So we're going to get this started. Thanks very much for coming. I see a lot of new faces, and I really want to welcome you to this. We've been doing this since 2001. It's a kind of a cool community, and you can meet a lot of different people, and hopefully you'll be able to network things together. My name is Joe Dillon. I'm the founder of QASIG and of Quardev, and this is Quardev, so if you're interested in anything about that, just talk to me or Chris or anybody downstairs. But I don't want to take any more Keith's time because he's one of the most compelling speakers we've had. It's his second time speaking at the QASIG, and I'd like to welcome him back. Keith Stobie. Thanks.
So I'm still working on the title. In fact, I decided now should be called May's, M-A-S-E is probably the better term for manual, automated, scripted exploratory. It's all going to be about those four words and combining them in different ways and what we know about it. So if you want to know a little bit about me, you can read the slides offline. There are PDFs associated with the Ustream thing, and you can go read this stuff later. But I've been around for a long time and talked to a few places. So first, testing. A couple different quotes. Kemp Kainer defining what testing is, and then James Bach defining why we'll never finish testing in a very James Bach eloquent kind of way. But I want to focus, because there's been some controversy recently, at least on some of the blogs I read, about what testing is, and I'm going to give a definition of testing which I work with, which comes from the IEEE. Activity, which is a system or component, is executed under specified conditions, results are observed, etc. So that's what I mean by testing. That's what I'm going to be talking about. And then there's the different levels of testing. We all know we're not going to do exhaustive or complete testing. I presume everybody already knows that. There's this word called comprehensive or pragmatic, and I've never figured out what those words mean. There's even a book out there. Eventually, maybe we'll learn something about that. So my first question for you guys, first of all, I assume everybody's heard these words. Has anybody not heard of manual testing? Not heard of.
Oh, not heard.
Not heard of automated testing. How about not heard of scripted testing?
I've heard of it, but I'm not sure what the definition means.
Fair enough. Good. We'll come back to that shortly. How about exploratory testing? Anybody not heard of exploratory testing? Okay. I ran across this quote, which turns out to be very relevant, because as we talk about different types of testing and whether or not they apply, there's a certain presumption about who they apply to. And so James is talking about the traditional tester, which I recently met some. And it's kind of interesting because a lot of what I'm going to say will not work with traditional testers. There's only a little bit of this, which is what works with traditional testers. I'll point that out as we get to it. So manual testing. What do you think of when somebody says they're doing manual testing?
They're the one doing it.
They're the one doing it. Okay, what else?
Exercising the features and functions of the software the way a user would.
The way a user would. Okay. Anybody else?
Ad hoc.
Ad hoc.
Not necessarily, but it could be to some verbiage, like in English script, it says the user does this, or the user contacts with this and access steps.
Okay. So we're going to explore this a lot more, but I'll go through the other ones briefly as well. How about automated testing? What do you think of?
My machine is doing it.
Your machine is doing it instead of you, okay?
It's not by program.
It's what?
It's not by program. It's set scenarios or set scenarios run by our computers.
Okay, set scenarios run by computers. Okay.
Run a VM in the lab for us.
Okay, run in a virtual machine.
Software minus UI.
Software minus UI. Okay. Well, this actually has a lot written about it. Here's at least 5 books you can read about nothing but automated testing. And I need to walk around because I've sat over on the side where you can't see the slides. So, also, I'd like to thank everybody for coming out on a beautiful, almost warm, sunny day here in Seattle. For those watching on the stream. Scripted testing. Does that conjure up any thoughts to anybody? What does scripted testing mean?
Following established protocols?
Following established protocols, okay?
Following a specific set of steps.
A specific set of steps, okay?
And looking for specific results.
And looking for specific results, okay. Anybody else?
They're running a test procedure from the most dependent code, so you might be calling test libs or the product directly to make some scenario happen.
Okay, something to make the scenario happen. So this is kind of what I've seen as examples of scripted testing. I found a wiki which is not very well authenticated. You know, some wiki pages are well reviewed and others not. This is a not well reviewed page. But I think it conveys more or less what I think of as scripted testing. A set of instructions or steps to follow in a prescribed sequence. That's normally what I think of. Exploratory testing. What do you think of?
Fun, play, using my experience to go to areas where I believe there may be an issue that was not called out in a scripted test.
Okay.
It's actually more like an ad hoc testing in a way that you're trying to break a system, basically.
Okay.
State-driven testing?
State-driven testing is exploratory testing, okay?
Discovery.
Discovery, all right.
It's the process of simultaneously learning the software, coming up with test ideas on what to test, and finding bugs.
Okay, good. So, term coined by Ken Kainer. This is one of James Bach's definitions. It's the one I'll go with, simultaneously learning, test design, to test execution with an emphasis on learning. There's a book on the subject by Dr. Whitaker, who talks about tours in exploratory testing. I went around the web looking at exploratory testing, found this website on an MSDN blog, lists all kinds of wonderful quotes about exploratory testing. But going back to Joy's point, I really think the way you think about it is it's this cycle of learning, some test design, some execution, some analysis, some learning, some test design, some execution, etc. So I find that exploratory and scripted, which are two of the ones we talked about, is this continuum. Okay, you start off, exploratory you can do even when you have vague understanding sometimes. And as you learn and explore, you might discover, hey, that was so interesting, we probably want to do that again and again. And in fact, we might even want to do it the same way. So we get closer and closer maybe to scripted tests, where we have a specific sequence. So we have that continuum. But to me, there's this other dimension, which is it manual or is it automated? So I have to briefly throw in a term because it's going to affect later on a test case. When you talk about, most people talk about scripted testing, they're usually talking about test cases, okay? Which is some set of inputs, execution conditions, expected results for a particular objective, etc. So exploratory and scripted are this continuum. On the right side, there's different levels of exploratory. You have totally free-form, freestyle. You have tours, for instance, like out of the book by Dr. Whitaker. You might have a charter, which says, you're not going to explore everything. We want you to focus in this area, okay, at least for this session. Somewhere in the middle, you have what are called fragmentary test cases. You can do both. It's not an either or. It's a blend, right? Oh, I can use a script for this part, and then I can play around, and then I can script and go around. And sometimes you get all the way over to pure scripted, which is, I don't do anything except what the script says. Oh, I shouldn't, oops. I'm far about that. Poll again. So there's a lot of interest in these two. A lot of folks have some views. Which way do you think finds more bugs?
Exploratory.
Okay, any other views? Interesting, okay? At least of the studies that I've read, no dramatic difference in defect detection efficiency between exploratory and test case-based testing. Or difference in critical defect between the two approaches is statistically significant. ET is more likely to find behavioral issues. Scripted tests more likely to find technical. Both approaches missing defects.
So you're talking about automation time, like the act of automating this test case as well as running in the lab on a regular basis?
I believe in this study, yes, they were probably including the folks as they were writing the scripts, but I suspect what they were doing is thinking about it, writing a script, yes.
So are you saying that they counted the bugs they found when they were writing the script?
I believe, at least in this study, the answer is yes, because my belief is what they did is they had a certain amount of time, and they told one group to explore, and they told another group to go write scripts and execute them.
Thank you.
And the references are here. You can follow up and read them. They're quite interesting studies, both of them. This one actually gives a comparison of 4 different studies. But basically, it's interesting because a lot of people have opinions about how this stuff works. And so I'd like to see where I can find some data.
Yes, comment though. I think, to me, it seems kind of biased because if you're including test case development in this, there's a certain amount of exploratory testing that kind of goes on when you're doing test case development.
Okay.
If you have your established test cases and then you just re-execute them every release, every build or whatever, I think you're going to find a much greater disparity between scripted and exploratory.
I'm not sure that's always true as well, but I haven't seen studies on that. Okay. Again, the reason would be if you're doing exploratory on a pretty stable product that only occasionally has major problems, the scripted test probably runs much faster than for the time it takes them to find the defects versus the manual exploratory. It could be a win. So I know one of the controversies on the exploratory versus the repeated regression type testing is does regression testing find bugs? Different people have different experiences. My experience, it finds bugs. Where I work at TiVo, we have failed tests on the regressions, unfortunately, too frequently. Okay? Maybe you guys are much better off processes, but if they weren't working, I suspect people actually wouldn't use them. Automated or manual. So it's a continuum, as I said, but some people, or many people, argue that it's actually unfair to call it continuum. That's what James Bach will say, with manual tests cannot be automated. A good manual test cannot be automated, all right? Or if you have a great automated test, it's not the same as the manual test you believe you are automating, okay? This goes back a lot to the fact that James is using a different definition of test than what I did when I gave the IEEE definition I gave. So if you can truly automate a manual test, it couldn't have been a good manual test. So now we're having judgments. This is a good manual test. That's a bad manual test. Okay? Good ones and bad ones. If you read and hand execute the code, you do exactly what it tells you, you will perform a poor manual test. I'm sorry, at TiVo, we pay people to do that. And they are not poor manual tests. They are very good manual tests. And I'll explain more sometimes when it's appropriate. Because, again, it depends on your context. Yes. Right? There are contexts where this is extremely appropriate. I'm not saying always, and I'm not saying it's misused, not misused, it is. But I don't think it's always that way. So, technique versus approach. Exploratory is an approach. Scripted is an approach to testing. I put in red this quote because I got these, this text came from 2 different sources. And the one source in red said that manual is technique, but I do not believe, I think they miscategorized it. Manual and automated to me are approaches, just as exploratory and scripted are approaches. So those dimensions that I showed you earlier, I believe are all approaches. Within that, you have techniques, functional, model-based, all this other stuff. But I think all 4 of those are approaches.
So Keith, I have a question about the manual testing as you describe it as let's suppose I have some scenarios that have not been automated. So I'm in a portal and I'm going to say, bring up this page, click this button, enter this text, and fulfill the scenario. So now, I think what you're saying is that it's a poorly done manual test. But
what is a poorly done manual test?
That's a poor manual test. Or what I've done. Did I misunderstand?
No, I think you did understand me. I don't consider that a poor manual test necessarily.
Oh, okay. But if you're going to reproduce it, let's suppose for some reason we don't have the budget to automate it, for example. So if I run a set of manual test cases, I need to do the exact steps. And it still has value over the automation. The automation has value too, but it's not a waste of time, because through manual testing, you can make many, many verifications that cannot be automated.
That's part of what I will get to.
Okay, I'm sorry. Yeah,
Yep, exactly. So a word that several folks used when I was talking about exploratory was ad hoc. And I want to distinguish ad hoc from exploratory, because I don't consider them synonymous. Or even random. The important point which James makes here is the extent that the next test is influenced by the result of the last we did. So pure random tests. Do a test, don't care what the result was. Do a test, don't care what the result was. And I see a lot of ad hoc testers do the same thing. I'll try this, and then I'll try that, and try this. A true exploratory tester is looking at each result, and based on that, doing some reanalysis, some redesign. That's, to me, the significant difference between ad hoc and exploratory. So I do not use those terms synonymously, just to be clear.
Now, Keith?
Yes?
Do you distinguish random from ad hoc? You put it on the slide, that's why.
I know. I completely understand the question. I think they're much closer. The difference, I would say, there is I've never heard of ad hoc automation, so I'm not sure what that would mean. So ad hoc to me is usually always a human activity of some form.
Today someone hit me with the word stochastic.
Ah!
And they asked me to distinguish between random and stochastic, and I couldn't figure out how to.
To me, those are synonymous.
Exactly.
Okay, so stochastic and random to me are synonymous. Ad hoc is kind of human random.
So it's your favorite random?
What was that?
Your favorite random?
My favorite random. Actually, it's not
Jim
human.
Lynn coins that. My favorite random number.
Okay. Another dimension that you have to look at in terms of those four that I mentioned, besides the technique, is the people and how you work with them on these things, especially regarding the automation. Okay? So if you're going to automate, if you're starting off with manual, ideally sometimes you want a domain expert. And there's a lot of techniques and tools out there right now to help domain experts do automation without knowing how to automate. Okay? You can start with things like Gherkin, which is a language for a tool called Cucumber, or RSpec, which is another way of specifying stuff, or even Fit, which is a tool which is a tabular representation. Sometimes I just recently started running into tool vendors who have scriptless testing. And what they really mean by that is non-textual script testing. But the way they build their scripts is through flowcharts in a graphical language. So you have graphical symbols, and you pull them into your plate, and you link them together, and now you have a flowchart. So it's a flowchart, not a script, or something like that. A little less obvious once you get down, it would be what the older keyword, action word kind of frameworks, which again are a way of doing sort of what Fit does, or maybe a little more generally. On the other end, you have stuff that's very close to what coders do, to what you really need to know software. You want to use XUnit, which is things like JUnit or NUnit or any of the other unit type test frameworks. You're down there in the software. There's all kinds of test libraries which are down there in the software. So where I work at TiVo, some of my testers are pure domain experts. They had no idea how to write code. Okay? Maybe I showed them Gherkin. They loved it. They said, "Oh, that's how we should write our tests." Okay? So you have to look at where you are. What I found unproductive is we have one person on our team who's a pure coder. They don't understand testing. They don't want to be a tester. They just like to write code. And so their job is to automate tests by not understanding what a test is. It doesn't work very well. We have to give a lot of rework, a lot of feedback on what they've done. So why do people automate? They hope to save a lot of money. I wrote the word goal, because this is how it's pitched. All right? I've been doing automation all my life. It rarely works out this way, is my personal experience.
I just have a picture of you as a little tiny baby with your keyboard.
Commodore 64, that was what I was a few folks know what that is. Okay, so this is the focus of my talk, which is not those 4 dimensions, but their combinations. All right? Because too often, I think people have already pre-associated words. Some people have assumed that when I say manual, it means exploratory, because you would never do a scripted one. Other people assume when I say automated, it means scripted, because how can you do automated exploratory? But I believe all 4 of these are valid. And this is what I want to focus on. This is what actually the talk is about, the reason for the weird title. Okay? These 4 dimensions, these 4 different ways of doing things, is what we as testers should sometimes be thinking about in terms of choosing our approach and therefore techniques. And what it listed is what my observation is about some of the characteristics. Exploratory testing doesn't guarantee any kind of coverage. I've never seen anything that tells me, oh, I got this kind of coverage. It does use lots of heuristics, which are quite useful. Scripted testing requires some knowledge of upfront test, because the definition of most scripted testing is not only do you have a sequence, but you're specifying what the expected result is. So you have some prediction.
Could be algorithmic.
Could be algorithmic, true. But what algorithm do you use? So you have to have some knowledge. Automated obviously requires hardware and software. Everybody hopefully knows by now, the major problem with automated tests, from my perspective, is it may miss side effects. Automated does what you told it to do and has no idea what else is going on. The fact that the computer blew up in flames, it wouldn't know. Okay?
That's why you write verifications.
Yes, if you can think of all the verifications possible.
You can't.
Exactly.
You can't implement it, so you.
So that's the problem with automated. Manual requires human, maybe computer assisted. And my experience is most humans, and I'll talk about an exception in a moment, miss minor issues. Which is, it's well known if you talk about like looking for spelling errors. You can, it's documented. We humans are very good at passing over spelling errors, in general, most people. Or, oh, the fact that this is off by a pixel, many people won't pick that up. The computer will, which may or may not be important. So, my experience, I've been doing this for a long time. I've mostly been an automated script tester for systems and back-end systems. So, I'm going to be speaking first about my experience and then combining it with what I've researched to give you some ideas about all these 4 dimensions for different kinds of types of testing. I've done tools for exploratory API testing before it was easy to do with debuggers. So a long time ago, I wrote a way, which wasn't common at the time, that you call the API from the command line. I had all my testers going, oh, hey, let me try this. What happens when you do that? So it's great. You can do exploratory API testing just by, what shall I try? Let me learn about the API by dynamically typing to it. Large-scale system testing under load generators. So random testing, mostly, but also you can have guided testing. And that's what I'm going to get to when I get towards the exploratory, the automated exploratory. I am not an experienced manual tester, whether exploratory or scripting. I have done some. I'll give a few examples. It's not my area. I do know a lot about model-based testing. I spent 3 years doing it, teaching 300 software engineers to do it. So I know it can be done. And again, limited GUI testing. So manual exploratory. When I worked at Bing, we were all, every tester in the organization, no matter what you were doing, and the managers, were required to spend 1 hour a week playing with the product like a user, regardless of whether you're working on the back end or the AI or whatever it was, and report your results. So I did that, but my favorite example from this was from my manager, Ken Johnston. He went in there and just, okay, if you think about Bing or Google or whatever, there's a category called images. So you can say, I want to search for images. So I just picked the first one letter, what A and B and C, it's like, what do I get from my images? And think about it. Well, who would type single letters? Well, maybe your daughter, when she's learning the alphabet, is kind of curious about letters. What might she get?
Yeah.
Yeah. So this was the kind of defects you can find easily with exploratory testing. Okay, these are recent examples. These I pulled off last night. They're better than they used to be, but you can still see stuff. Another example, this is kind of a different way for me of doing exploratory, which is, again, I'm not much of a manual tester, but I do like to explore. And so rather than exploring the UI, exploring the logs, what I call now big data, which is how can you use information about how your users use the system to find defects? So we have this thing called abandonment. And first of all, how many of you, when you, it's less prevalent now because actually browsers have made it even more confusing. There used to be always this search box and a URL box for your browser, okay? And I, as a computer professional, would type URLs in my URL box and searches in my search box. How many people do you think type URLs into the search box?
My parents.
Your parents, exactly. Turns out 20 or 40% of the population does. And if you notice now, most browsers have one box which does both. And so these are called navigational queries. So the question is, if I type, I'm on the images page, and I type Sears.com, do you think I got what people expected to get? Did you shake your head? Why?
If I typed it in there, I'd want their catalog. But
You'd want their catalog. Wow! That's what we observed in the logs. The way we observed this at the time was people would be on Bing, they type it 2 or 3 times, they wouldn't get the result, and then we could see that they switched to Google. That's called abandonment. Okay, it's not going to be what I want. All right? By the way, that's not back then. Which screen, those 2 screens, those are 2 different search engines. Do you have any idea which is which?
That's Google.
This is Bing, that was Google. So that's an example of, we improved the UI, we found a bug by looking at logs and what people did and saying, hey, these folks are frustrated. Okay, so here's a more recent typical exploratory bug. This is on our UI, website. So I can program my digital video recorder from the website. I can go find this program and say, oh, I want what's called a season pass. Record all the sessions of it. So I go ahead, I click on it, and I get this, which in case you can't see it, I enlarge. It's this overlapping text. Okay? Humans see this instantly. If you program it just to read, did the text show up in the XML, without looking at how it's positioned, you might say this test passed fine. The difference between human and machine. We have a lot of manual test scripts at TiVo. This is an example of one. This is actually a very typical one. We have automated, so TiVo is mostly controlled by a remote. So we have automated remotes, so you can automate it and send keystrokes without actually physically having a remote. There is no keyboard on a TiVo. There is only the remote. So all these button presses is the way you control the system. Here's a very short example of a manual test. Verify you can tune to a cable channel. Key in the number, verify you can see it. So we automated it. We happen to automate in what's called Perl. It's a programming language. We have a library of scripts that interact, so automated. We go to our central screen. We go to that channel number. We say, go get the screen dump, see what the channel's tuned, and does it match? A lot longer than that manual test description. And in general, it's been shown that automated scripts done from manual take about 10 times as long to create, either because of the length of the script or just the complexity. So it's well known that return on investment for automated only occurs if you do the same thing a lot of times, way more than 10. Automated exploratory. How many of you have ever done automated exploratory testing? I got 2 or 3 hands. Cool. So for the rest of you, this is new then. So, to me, random testing is borderline exploratory testing. It's not exploring in the true exploratory sense, which is pure random, as I said, doesn't look at the previous result to say where to go. But if you're new to automated exploratory testing, it's not a bad place to start. So you can look at things which are called dumb monkeys and fuzzing, and I'll go into more details on these in a moment. You can do random stress testing on your system. My experience on this is with many different tools. I did it at a previous company called Tandem, which was fault tolerant, so we had to introduce lots of failures. I've done a lot of model-based testing, which was, again, a way to explore things. Monkey testing, how many have heard of it? About half, okay? It's been around for a long time. There's various names for it, dumb, wild, unmanaged, whatever. Random is the key word there. So I'm going to talk more about smart, trained, or managed monkeys. That's where you're starting to get to an exploratory monkey. Okay? The exploratory monkey applies to the detected state. So notice, like an explorer, he does something, he looks, and based on that, he decides what to do next. It's not blind random.
You can always record the steps as executed. If I'm doing random, I still want to be able to at least review them.
Yes. So, do you want to repeat them? And I don't want to express this properly. For simple tests, it's generally good to record that. Under certain circumstances, when you're doing random to generate load, if you do that, you spend so much time logging that it affects your ability to load the system. But in general, yes. It is nice to do a log in such a way that you can replay it. That's just good practice for how to actually do random testing.
That's how you do it.
Yes. If you're looking for a free tool, there's a wonderful one from Netflix released to GitHub called Chaos Monkey. Now, theirs is specifically designed for running in the cloud on the Amazon Web Service, which is where Netflix runs, in case you didn't know. And what they do is they go around randomly killing parts of their service all day long. And if you can read the articles, the blogs, and the other studies. When Amazon has had big failures, like about a year ago, they had a big failure. A lot of companies that were based on them failed. Netflix did not. Netflix is more reliable than Amazon was. Okay? In general. Now, Amazon tells everybody how to do it. It's kind of like the old days when you told everybody how to do backups, and then when they had to restore them, it didn't work. Right? That's how cloud recovery works today. Oh, follow these 100 practices, and then when something goes wrong in your underlying service, you'll be okay. But how do you know that? Unless you actually do it. How many of you are familiar with the term fuzz testing? But less than half again. Okay, so I get to tell my favorite description of what fuzz testing is. How many know what the word fuzz testing came from? Oh, fuzz testing. It comes from, literally, a dark and stormy night. A dark and stormy night, a CS prof was on their computer talking over a modem, probably like 300, 1200 baud modem, across a phone line, analog phone line, to a computer when there was a lightning storm. And they noticed that because of the lightning storm, the computer didn't always receive the letters across this analog modem the way they typed them. They got fuzzed. And so that wouldn't have been so bad, except they noticed that all these Unix programs that they were typing to at their command line prompt were crashing when they got the wrong inputs. And they thought, shouldn't these things be able to handle that? And they wrote the first fuzzing program, which was random inputs at the command line to Unix programs, and they found out they crash on all of the different versions of Unix. By the way, if you want to learn more about fuzzing, I would highly recommend this one, OWASP tools list. Fuzzing has been really adopted by the security community because that's actually where people found it to be extremely effective, more effective than human. This random testing, more effective in general than humans at finding vulnerabilities, the kind that you hear about people taking over your computer with. So my take on fuzz testing. What it is pushing invalid data as far into the system as possible. Okay? You want to explore, ideally, explore how you get further and further into the system to pass it bad data. Because all systems have these wonderful defenses at the beginning. And if you do security testing, you'll hear this concept of defense in depth. So what you want to do is keep breaking down those defenses and find out how deep is their security. Again, you have dumb and smart fuzzing. Dumb fuzzing is basically random. Smart fuzzing knows about how it is consumed. The more detailed, the better. Several of the most famous bugs against Microsoft, like some of the worms and things that would crash computers, were found because they sent the first 3 messages correct. It wasn't until the 4th message that they sent bad data. And that's when they would actually do something nasty. There's 2 basic ways you can do fuzz testing. You can generate your input from scratch. You create a totally random string, totally random set of data, and send it. That is still a favorite because that, believe it or not, because it's random and because it's not doing what you would think of as exploring, which is learning, it's exploring the state space in a way humans never explore. Humans never explore a state space totally randomly. It's not in our nature. So when they do pure random, the dumb stuff, they still do dumb exploration because it still finds issues that humans never thought about. The other one, mutation, is what you do is you take legal input, say, okay, well, this is good, now let me flip a bit somewhere and see what it does. Now, the interesting thing about mutation is not every mutation is necessarily illegal. Okay? But they don't really care. What they're really looking for is not whether they get a legal or illegal response, they're looking if they get no response at all, like maybe the server died. Ooh, cool. That's called the denial of service attack. Yes?
Have you ever run into conflicts with like architecture teams where just because you can test for something like that doesn't necessarily mean if you find a defect it will be warranted?
Oh, absolutely.
And in regard of the dumb monkey, I've run into that before, where just because we could find it doesn't necessarily mean it's cost effective to put that kind of logic or capability to capture it in the system at large.
So you made 2 points, and I'll distinguish them because I think they're both good. On the security side, many developers have often argued, oh, you found this, but, nobody can exploit this. That's what it's called.
Nobody's going to do that.
No, not that nobody will do it. They can't exploit it.
No.
Even if they do it and they crash it, it won't do any harm. Okay? Oh, yeah, you found this thing that I use 3 extra bytes when I print my error message. That's not going to do any harm. Unless I print your error message over and over again until you run out of memory. How many times do I have to do that? Oh, 1 billion. How many messages can I send a day? About 1 billion. So in one day I can crash your server. That debate went on in Microsoft, which is where I was at the time, a lot, and it got squashed pretty quickly. There was a classic memo that went out. I loved it. When I joined Microsoft, they would treat all kinds of bugs like that 3-byte buffer overrun. Who cares? Nobody either would do it, or even if they did, it wouldn't matter. Gates sent out a memo, which was great, saying, we're going to respond to all security bugs. So now, anytime I found any kind of bug, and they wouldn't fix it, I'd say, how can I exploit this? Literally, as a security bug, because they don't get fixed. So your second question was, how about when you do dumb monkey testing with your UI and it does something nasty and it crashes? It depends on its context. It depends on the UI and your company and what it cares. One way is, and many products do this, if you do a quick enough reboot and you restore the state, it won't matter. That's a method of dealing with that. In fact, that's actually a very good way of doing it. And this is the cloud methodology as well for failures. Rather than trying to prevent all failures, if you can restart fast enough, you don't have to worry about if you can prevent all failures. It's better to fail, it doesn't matter how, and then snap back. That's the key. So your developers may or may not have a good argument depending on context there. It depends on what reliability you expect and what your customers expect. Different levels from different products. I'm going to skip over this because we're getting short. Expect Explorer is a model-based testing tool. I'm going to skip on that as well. It has what's called on-the-fly testing, which I will talk about briefly. So model-based testing tools, somebody mentioned state space and state space exploration. they actually have a model. Frequently it's what's called a finite state machine, which is like a giant, sort of complicated flow chart of different things you can do at different times, the state. And so what a state-based tool lets you do is keep generating inputs, kind of like the smart monkey saying, based on what I can do on this screen or what I can do in this state, here's what I'm going to do next. And then you can automatically explore that. And for small models, you can actually exhaustively explore it, more or less, except for loops. But for real models in most systems, you can't. So I'm probably going to skip over most of these as I'm getting a little short on time, but I'll briefly discuss a couple things. So I pulled some stuff off the web, seeing what other people said about manual testing. And I see a lot of biases and assumptions which I don't believe true. So I highlighted in green, like all these things, are the only ones that I tend to agree with. Okay? Advantage of performant manual testing, to me, is it's performable even when the application is not stable. Okay? One of the real problems with automated testing is you have an unstable system, you spend more time maintaining the automation than anything else than discovering what's going on with the product. Humans are very adaptive. Computers, not so. Disadvantages can lead to defect due to human miss or error, as I mentioned previously. And these are all different ways of saying things change a lot. Manual or automated effectiveness. I don't agree with most of this in terms of, I think both approaches, both automated approaches and manual approaches can be effective for any of these. Take sanity or smoke. Is sanity or smoke good to do manually? Well, if you have a very unstable product, possibly. Okay? Which is, if you got an unstable product and you need to check the sanity and smoke, you might want to do that. And what I mean by unstable there is the sanity and smoke you want to pass, but there's a lot of other things that are still changing dynamically. Oh yeah, the UI is completely different every day because the UI folks haven't figured it out. But we have to go through the UI for some reason because it's badly coded to get to the functionality that we're supposed to smoke test. Try doing that automated. Granted, eventually, hopefully your testing will figure out how to automate below the UI, but not everybody has. Scripted and exploratory testing. Again, there's some things on here I kind of agree with. Scripted testing is more confirmation usually. Exploratory testing involves investigation. I'm not sure I completely agree with that, which is part of the reason that I think manual scripted tests aren't the same as automated scripted tests is most humans, when they're doing manual testing, even if it's scripted, are investigating, whether they know it or not, whether what they're seeing matches what they expect, even regardless of what the script says they should expect. So there's always a little bit of exploratory testing. Skip this next one. I'm going to skip this one as well about computer-assisted testing. Random testing issues. So what's the problem with doing random testing? I don't think random testing is used enough, but there's lots of reasons not to use it. The biggest one is verification of the result. Okay? One great place to use random testing is when it's easy to verify the result. Examples. If you're testing your new version against your old version, and your new version is supposed to be compatible in all ways with your old version, one way to test is randomly send stuff to the new version and the old version and see if you get the same response. Yes?
If the goal of testing is not to assess correctness, but to assess robustness, random testing has proven very, very effective in many of my clients.
Absolutely. And it's not so to me, robustness is a type of, I'm sorry, the first word you used was correctness.
Correctness doesn't matter.
Correctness does. In there, it's correctness of the system staying up. That's what we mean by robustness.
Something like that.
Yep.
Something to that effect.
So I got an education on this one 2 decades ago, I guess, from James Bach, when I told him, I have no expected result from my random stress testing. He said, yeah, you did. You have a prediction. And your prediction is it does not fail. That is what you're verifying. So That actually is what we're doing. Very low probability subdomains. So random testing does what's most common on average, just because of the way it does it. So when the cost of failures in certain subdomains are very high, random testing will maybe never explore that. Example, you have a billing system and it has a monthly report and a yearly report. You could do random testing for 364 days of the year and have no chance of finding that yearly report bug, right? Unless, of course, you play with the time on the system or something like that. But that's just a trivial example. So to me, random testing is a great complementary strategy to all the other ones that you can use. And that's where I believe it's underused. I don't think I've never seen it as a sole testing strategy, which is the only way to test, even for security. Okay, while fuzz testing is great, there are other things you should be doing in security testing as well, like playing with timing. I'm going to skip over requirements confirmation versus design confirmation.
Can I just ask one point?
Absolutely.
It's just, it happened to me in Washington last summer, and
Okay.
it scared me. It scared me. It's the notion of what the word random means. And there's a new generation of young whippersnappers out there who conflate the terms random and arbitrary. So if you just say random is arbitrary, that's not the same thing.
No, not quite.
What you mean is random is a uniform random distribution or something like that.
Yep, exactly.
So I just thought you might want to
I mean random as stochastic. Thank you, I will add that in there. Probably along the lines of ad hoc versus arbitrary.
A lot of people today say, hey, that was a random thing that happened. And they don't mean it was a random thing, they mean it was arbitrary.
Good point. The words in our profession.
Young whippersnappers.
Yep.
Gotta listen to them.
So focus on how we do our testing a little bit. So I'm going to talk about techniques and then bring it back to these four approaches, 2 different techniques. That will be kind of the final. Basically, we have business-facing, technology-facing, or you can also add the idea of whether your technology-facing is supporting the team or your business-facing is supporting the team, how you're going to critique the product. So this one, you're doing confirmation, right? You're trying to say, yes, it works. And in this one, you're trying to say, no, it doesn't. And by the way, I've seen testers who work so hard on showing no, it doesn't, that they never find out that some of the stuff that should work doesn't, which is really important. So both kinds are necessary. And we can do them at different levels. Technology-facing supporting, unit and component tests. Functional tests, story tests, prototype simulations, those are your business-oriented things supporting the team. We want to show that it does this story. Exploratory testing, scenarios, usability, your acceptance tests, and having real customers involved. They're going to critique the product. They're going to tell you when it's not working. And then finally, other ways of technology is performance, load testing, security, all those kinds of things. So I didn't invent this. It was actually done up by Brian Merrick, and then this particular slide was done by Crispin and Gregory, and it's called Agile Quadrants. I found it a very useful way of thinking about testing, because there's so many different techniques. How do you, because you argue, some people only know one area. And they claim, they have some nice words here that fit in well with automated and manual. Again, I think you can do some automated testing here. I've seen manual testing done here, and sometimes it could be appropriate. They allow both here. And here it's interesting, they use the word tools. And by that, what I think they mean is computer-assisted testing, which is some human doing something using tools with a lot of automations.
Look, Keith,
Yes.
where in this quadrant would you put a type of testing that I'm a big fan of, which is business logic automation? Basically, you're running to a web service or a business logic objects in your client.
So your business logic is probably maybe a simulation of the business logic, potentially,
Okay, yeah.
or examples of the business logic. Did you have a?
No, it's exactly.
Exactly.
Yeah, it's just, you can test a lot more of the functionality though without the GUI because you can do lots of things that may be surprising.
Right, so this does not mention anything about the UI, whether you're going against the API or the UI or the web UI or whatever. So these apply against, regardless of where you're doing that. And I'm going to skip over these next 3 slides, unless I need to, I'll use them as backup. But again, people think of different levels of testing. You start off with your unit, you add in some smoke, regressional, functional, you get to your integration, then you add your load performance. Finally, you do some security and acceptance testing. I'm going to skip over that as well. A different technique, I like this slide, which is why I throw it up here on software testing techniques, because again, not enough people focused to me on whether or not you can do static testing. So people are talking about, oh, how many bugs do they find while writing their test cases? What kind of testing were they doing when they're writing the test cases? Exploratory. But were they executing? No. Actually, probably not.
Executing part.
No. You can write static test cases without doing any execution. You can write them.
You can.
Okay, I do it all the time. And that is a way of finding certain bugs. Okay? So, static testing is an area that people don't always talk about. Most people focus on the dynamic. But the other interesting thing, and this goes back to what Rob was mentioning earlier, this exit criteria for like a reliability model, as opposed to simply an adequacy criteria, coverage. So we don't talk usually about the coverage of robustness. We talk about the length of time of robustness.
Absolutely.
But we do talk about the coverage of features, or the coverage of error messages, or all kinds of other coverages. So a good way to think of it. I'm definitely not going to throw that one out in there. So this is getting a little close to my broad summary before I go into some detailed examples. Manual exploratory. To me, it's cost-effective, one-shot bug discovery. No coverage guarantees, but it's great for finding bugs. Tester requires extensive background or knowledge. What was it? Typical? No. The word from James Bach at the beginning, which I should know by now. Your non-expert tester, okay? Your typical, traditional, there we go. Your traditional tester, untrained, unexpert, unstudied, doesn't necessarily do exploratory testing well. Okay? Exploratory testing is a skill. Where I agree with James Bach completely is skilled testers is what we need. And in his example, skilled exploratory testing. Again, lots of heuristics you can use. Manual scripted, I mentioned, rapidly changing product. It can guarantee some coverage. The reason people do scripted testing is they can say with confidence, at least these samples work. Okay? And they can define for some coverage. The PM said these 4 scenarios must work. And I can verify that the 4 scenarios they said have to work. Okay?
And I can do it over and over again.
And I can do it over and I can show on every build, on every release, those 4 work. That's what it's about.
So what's the goal of testing then? Building confidence.
Absolutely.
There you go.
So manual exploratory won't give you that guarantee. That's what scripted does. And an automated scripting for a rapidly changing product can be too high. There's another reason, and this is one I alluded to a long time ago. How many people are familiar with what CAPTCHA is? What is CAPTCHA?
Turing test.
Are you?
It's an inverse Turing test, it turns out. What do you mean by that?
You have to identify the symbols.
Right. So a Turing test is a human trying to figure out if it's talking to a computer. The CAPTCHA test is a computer trying to figure out if it's talking to a human, which is why I call it the inverse Turing test. And this is a simple example. You've all seen this weird stuff. It turns out we humans have no problem reading that, even though that's a very strange P. You know, I'm sure my 4th grade penmanship teacher wouldn't accept that, but we can recognize this stuff instantly. But computers don't. It takes a lot of computer power to figure out what that might be. And so there's something that the AI folks have found called Moravec's paradigms, which is computers are really good at high-level things that we think of as hard, like logic and reasoning. And the things that we think of as simple, like playing table tennis, running, walking, those things are really hard for computers. So sensor motory things are things that humans are really good at, and computers are not. So for instance, if part of my smoke test is to make sure that the video on my DVR is playing correctly, Turns out it's really hard to automate. And hiring humans to do it is really effective. So for somebody to tell me without knowing my context that you should never have manually scripted testers doesn't know my context. Now there are commercial tools actually that can check the video. They cost about $300,000.
Yes.
We can hire people for about $10, $20 an hour. Okay, so again, there's this return on investment type thing, right?
An example of the videos and having humans to verify it because they can do it well. Is that the test itself is scripted, but the verification is manual? Or am I missing something?
Well, it turns out, I also mentioned this unstable product issue. Most of what we're doing is evolving our product. So most of the time we are trying to improve our UI on a frequent basis. We can download a new UI every month to your machine and make it easier for you, which is great, except for scripted tests that are automated. So again, we go back to humans have this great ability to adapt to a system that's changing and to deal with things which are difficult for computers, like CAPTCHA when you're logging in, or sound quality. We can hear problems. We know what sounds right and what doesn't sound right. It's just a human capability. Can you automate that? Yes, you can. Is it easy? No way. So again, return on investment. Manual scripted, again, may miss many things. Turns out there are people that love to do the exact same thing every time, pay total detailed attention. And they have something called Asperger's syndrome. There are companies that you can hire people to do this that are highly skilled, they're highly respected. They do this really well. Okay? So this link to specialist people was started off in Europe, and it's actually spread to the US. It's a consulting company.
Hire an ASPE.
What was that?
Hire an ASPE.
Yes. So it turns out some of them are extremely good at this, what we think of as repetitious, humans don't do it. Got to know your context.
Yes. The other context in which manual scripted testing is important is in the regulated industry, because that's all they care about, is demonstrating that your requirements have been met, and you have to demonstrate in a reliable way. So there's a manual scripted test that we write, that we follow, that shows the regulators like FDA that yes,
so
our requirements
I
are.
question that. Let me just ask.
Oh, yeah.
If you had an automated script that didn't just run instantly, and I've done this many times for demos, you can slow it down and say, now watch. See, you can see the screens and you can see.
Automated scripts will work as well.
But so
it's very scripted, but
scripted,
oftentimes
okay.
it's manual.
Yeah, scripted but not exploratory. Yes. So scripted again for confirmation. You know, these are my favorite scenarios. They have to work. Right.
But most of my experience in spaces that have regulations, regulatory spaces, Sarbanes-Oxley, FDA, all that type of crap, what you have is actually a focus on the evidence of your testing. And it's the evidence that they want to see. Whether it's manual or automated, they could actually care less, from my experience.
And they've
Because
got
they
data
really
to
want
align
strong evidence that what you did conforms to their thing. And that's, I think, another dimension.
Yes. Yeah, I haven't talked about evidence at all. I'll probably leave that out.
But that's what I think the people who are in the world of regulatory compliance testing are concerned with.
Seems like there's a synonym for manual scripted testing, which is bug. Like, I feel like I write a manual scripted test every time I report a bug. Because
A well-written bug, I would probably agree with you.
Yeah.
Whole other topic of bug advocacy and how to write a good bug, but I agree. A well-written bug is usually the equivalent of a manual script. Although many times, actually, actually, I will retract that. Again, so when I learned Agile testing from Elizabeth Henderson, she convinced me, and it was great. The way to get rid of a bug system, you shouldn't have a bug system, okay? What you should have is a set of tests. And when something fails, it's always a test failure. You say, there's the test you gotta go fix. You know, you gotta get the product of this test to pass. That's it. You don't need bugs. So there could be automated tests rather than having to, so the requirement could be to report your bug, write an automated test for it. I'm not saying that's always applicable in all contexts, but it's possible.
Write a failing automated test.
Yes. Well, we're going to do test. We're going to do test first, right? First it fails, then you fix it, and then let's see if it passes.
That's Tech 101.
Yep.
That's not sufficient to specify the scope of the bug if it's a specific scenario. Well, I mean, if you as well as, yes, you have a failure here, and here's the script that fails, and that itself is a bug. But you might not know about what the scope of the bug is. If it's every second Tuesday of the month, it fails, and you have to specify this script fails. But the context, the scope of the bug has to go in the bug as well. And so the script itself is not necessarily sufficient. Or
depends how you write it.
Or it's an intermittent failure. Well, maybe. Yeah.
Intermittent failure. Well, we have to report both manually and automated ones. Well, an intermittent failure, I can show you bug reports. 7 out of 10 times failed.
Oh, okay. And that's part of the script.
That's part of our bug reporting system.
It's necessary but not sufficient.
Right. Okay, automated scripts. We talked about missing many side effects, upfront knowledge. You use it when the manual script is expensive versus repeated automation. When you have a stable system, that's when you can do it. And this is what most people think of as far as I've learned, if I had to guess. By 4 words, most people think automated scripted, manual exploratory. Those are like the 2 major things. That's probably what most people do, and it's actually a great compliment. I mean, I think that you need both. Automated exploratory finds defects. So let me talk some examples. Unit testing, okay? Manual exploratory. I have seen some great devs go in their debugger and explore at the unit level bugs. So for instance, you can read about how to automate by creating mocks. Mocks can be very difficult and expensive. So you call this method that never returns a null, but you check to make sure it might return a null. How do you do that? Well, in the age you go to the debugger and you make sure it returns a null rather than writing a whole mock. That's a form of exploratory testing. Oh, well, what happens when you do this? What happens when you do that and corrupt that? I've seen it done. I have also seen, and I do not recommend it, which is the yellow, which I should switch to red, because that's my, is manual scripted unit testing. I've seen people who have debugger scripts that they basically go, oh, I'm going to try the same set of things in the debugger every time. I saw many people do this for years until they figured out that automated unit tests really weren't that expensive and XUnit frameworks took over.
So the context where I've seen that work is Carhartt, the company that makes protective clothing and stuff. And what they do is they throw all this life cycle crap out the door and they blend unit testing and user acceptance testing in one. And it actually works for them where they have scripted unit testing like that. But it's a context, it's very rare. It's only one place on the planet that it
for
works.
Unit testing.
But Carhartt blends customer acceptance testing.
And do you think that's an effective way for them to do it?
It's what they do.
Oh, I'm not saying people don't do it. Let me rephrase. I'm not saying people don't do this. I have seen people do this.
Okay.
My question is, would I ever recommend it?
Okay, sorry.
I recommend
I'm
this.
just giving you a case where it actually.
You're right. No, I've seen it done. Don't get me wrong. I've seen it done. I just don't recommend it. I'm not sure it's a cost-efficient thing.
No problem.
Modifying the debugger actually is a great exploratory technique in context. Automated scripted, hopefully you all know that. What people don't know about is automated exploratory. At the unit level? What the hell does that mean? Well, there's a tool called PEX. There's actually a fun little, you can go to this website offline called PEX for Fun. It's a model-based tool. It reads your code, it builds a model, and it automatically generates input and explores your code. And it automatically creates what are called parameterized or modeled unit tests. And it's not the only tool like that. I'm just giving an example.
Does JTest do that type of thing too?
I don't know, but it's possible. I'll go look that up. Yeah, I think there is a Java one as well. I don't know what it's called, and I should. So, good point. Functional black box testing is where you normally see model-based testing. So I talked a little bit about that when I mentioned Spec Explorer. There's not a lot of other modeling tools out there. So automated exploratory, you can do models very easily. You can start with really simple models. You can hand code them, or you can use tools. And the idea again is once you have a automated model, you can do it automated exploratory. And I covered the other ones. Automated unit testing. Oh, eCloud is another example. I love this one. So it creates an approximate test oracle from a test suite. What it does is you write a few tests. Maybe you already have a test suite lying around. You had some, what do we call, traditional tester who wrote some tests for you, right? Doesn't know how to write tests, but he wrote or she wrote a few tests. So this is your test suite. Probably not a great test suite. eClat looks at that and then it automatically generates inputs likely to reveal bugs and expose new behavior by creating a model from that test suite of the different things to try. So it learns from the tests instead of from the product what things it might want to try on the product that might not have been tried. We're not going to go through the example of this is how you can improve manual scripted tests. This is an example of manual exploratory. This is a notebook when somebody had a particular test session. And I think I'll conclude with this because I think I'm about over time and should leave some more time for questions. So Brian Merrick, if you don't know, is one of the original Agile Manifesto signees and also did that Agile Quadrants I mentioned. And he has a hypothesis, unproven, he says, which is totally true. I've not seen any data on this, that while automated test-driven development, so automated tests at the unit level, he thoroughly believes in, and it's cost efficient, it's the way to go. And he was trying for a long time to do automated business-facing tests, okay? What he's calling business-facing TDD tests, or you might call behavior-driven tests is a new fancy word for it. And when what you're doing is a UI or a GUI, he's no longer convinced that creating a full set of automated GUI tests, even for your stories, is a good idea. So his hypothesis is you should do more exploratory testing instead of automating or worrying about trying to automate some of your stories at the UI level. It's an interesting hypothesis, that it's cheaper to develop and no worse in quality. And at that, I think I'm going to stop there since I'm a little over time. Questions? Yes.
The other question, you said you taught model-based testing, and how many verifications of a test per a given scenario random can you program in there, other than does the system crash?
Oh, no. So with a true model, okay, so a model, if you create an extremely detailed model, which I don't recommend, but people have done, then you get down to what's called N-version programming. N-version programming, which has been studied and documented, is you write the same program twice. And you remember I talked about then you can then compare the outputs? Well, it can do everything. So it's not any one sequence. It's any possible sequence.
And what is your oracle then? And here's your system and here's the one.
So with N-version programming, and you only have two. That's good for testing. All it tells you is they differ. Now let me ask you, for those of you who have done some testing, especially if you've done scripted testing, when your scripted test fails, does that mean the product always had a failure? How many of you found that to be true? Nobody. Jeez, I guess we don't write good tests. Must be like software. So the problem is, you don't know which one's right? If you write the same program twice, you have two different people write the same program. First of all, you don't know which one's going to make a mistake in what. So they'll have different sets of bugs, to the most part. And so all you can do is say they differ. Furthermore, what they found with N-version programming, and the way that N-version programming has really been used for is ultra-reliable systems. They usually have 3 implementations, and then they have a voter.
Space shuttle.
Things like that.
redundancy.
Yes. But what they found even there, guess where the bugs come from at that point? Requirements or design, right? They said, this is what your algorithm has to do, and 3 different coders did it, maybe even in 3 different languages. And yeah, there were lots of differences, but they were still common bugs. All 3 implementations.
And the most extreme documented case of this that I know of was written by Tracy Kidder, and the book is called The Soul of the New Machine, and it's how Data General created a machine to compete with the VAX by having 2 competitive teams actually build the same mini computer in parallel without knowledge of what the other team was doing. And they did it, they kicked ass, they did it, but man is it expensive.
Oh yeah.
Man is it expensive, and the costs are incredible.
So going back to the model-based testing for a moment, that's the extreme case. So to me, what you do with models is, and I don't have time to go into all that, that's why it's a whole other class, is you abstract away a lot of things and you focus on a certain area that you want to, certain set of behaviors you want to deal with. And so there's certain aspects that the model won't test, but for the things that it does, it can do an infinite sequence, because that's what the model does. It says, for this area of the product, I understand everything it can do. In fact, I can do everything it can do, and because of the way these models are written, I can automatically go through all the possibilities of what it can do.
But how many verifications do you think is really effective to implement and then bring value to the team with the model-based testing?
It depends, well, it's very context dependent, it's also size dependent. You give me a 200-line program, I don't know, maybe 10,000 verifications. You give me a 2,000-line program, I don't know, 2 million, 20 million, I don't know. The interesting thing about...
I'm sorry, to clarify my question, I meant like individual values, like properties of a system, for example. I'm going to verify, that's one verification, rather than a bunch of different scenarios.
As few as you can to get the most confidence you can.
So that's true, but for the models, so what I didn't explain is, the models, for every parameter that you're talking about, you have domains, right?
Yeah.
So you specify the domain in the model, and then you choose which is what you can automatically choose exactly what a human does, which is a strategy. Your strategy could be, oh, I'm just going to try the boundaries. Or I could try to say, my strategy is try the boundaries and one in the middle. Or whatever your strategy is, that will determine. And what's going to be cost effective depends on the individual product, etc.
To point out research on that, there was a whole field of testing called clean room testing. And what they spent was basically 15 years trying to find a statistical model where they can actually answer your question. And they didn't come up with an answer. People are still trying to figure that out. We don't really have statistical models, and until we do, we can't really give you a number.
Right.
What we can do is say, if you can keep testing economically, never stop, never give up, never surrender. Just keep doing it and be, clever and mix in as much variety as you can. And you're going to expose cool bugs.
Yep, that's my experience too.
There you go.
You used the term static testing, and I'm drawing a blank.
Oh, static. Static is not executed.
Non-execution.
So going back to the slides,
Compiler of intelligence.
a compiler is an example of static test. Have you ever gotten an error from a compiler?
Right.
Your compiler found a bug in your code. How did they do it? It didn't execute your code. It's static testing. If you ever ran something like lint or whatever, all these different tools are ways that can automatically analyze it. Have you ever had your code reviewed?
Okay, sure.
Did they find bugs?
Right.
Did they execute it?
Okay.
All of that's considered static testing. Not executing the code, but still finding bugs.
Gotcha.
Okay, well, thank you very much. What are you down for?
I don't know, I just heard you were here, so I dropped by. Good to see you, buddy. I really got an email saying Stobie's doing talking Quardev. That's cool. So I said, can I drop by? I said, sure. I hope I didn't interrupt you.
No, sorry, I was recycling. Does anybody want to stick around for the door close? Because